Good morning, students. So we'll continue with quiz 4, and this is for BTech 6M Textile Technology, Textile Chemistry, Textile Engineering students under the subject Textile Testing. So the first question is the property most related to thermal insulation of a blanket. Thermal insulation of a blanket is basically related to thickness of the blanket and the air pockets formed inside the blanket. So the given options are tensile resilience, compression resilience, thickness, and surface friction. So we can see both B and C option are related to thermal insulation, but if we have to choose one option, we'll go with thickness, that is C. In the context of flat fabric, abrasion resistance, choose the correct statement. Abrasion resistance of fabric increases with increase in yarn twist continuously. With increase in yarn twist, initially abrasion resistance increases, but after the optimum twist, it decreases with increase in yarn twist. So option A is incorrect. There is no optimum fabric set for best abrasion resistance. There is an optimum set. After that, if we increase the set, and that is EPI, PPI of the fabric, the abrasion resistance reduces. So this is also incorrect. And the last option D, that is yarn made from long and short fibers, do not make any difference. Yarn made from long and short fibers, they make the difference because short fibers will have more hairiness. Those yarns will have more hairiness, and the more hairy yarn will result in lower abrasion resistance as compared to the fabrics made from yarns made from longer fibers. Now the correct option is C, that is the pressure between abradant and sample can alter the ranking of a set of fabric for a particular abradant. Now we'll go to question number 3, that is with an increase in the friction between the yarns, the tear strength of a fabric. The tear strength of the fabric will decrease with increase in friction between the yarn. The more looser the structure, the higher is the tearing strength. So we'll go with option B here, that tear strength will decrease. Next question is related to tear resistance of the fabric. The tear resistance of woven fabric increases with increase in yarn to yarn friction. As yarn to yarn friction increases, tearing strength decreases, as we have already discussed in the last question. With increase in yarn strength, tear resistance increases. With increase in thread spacing, that is the looser fabric, tear resistance increases. With increase in float length, tear resistance increases. So the correct option is Q, R, S. These three statements are correct. So we'll go with option B here. Now next is when twist is increased in a spun yarn, its strength. As we all know, the yarn strength first increases with yarn twist and then decreases spun yarn strength. So we'll go with option D here. Now the next question is, in a tensile test, if the strain rate is increased, what is the effect on apparent tensile strength of ring spun yarn? As we all know, rapid loading gives higher breaking load. As we increase the strain rate or as we increase the speed of the testing machine for strength testing of the yarn or if the strain rate is increased, the tensile strength apparently increases. So we'll go with option A here. The next question is the ratio of fabric strength per thread and single thread always is greater than unity due to the fabric assistance factor, because the cross threads also contribute to the fabric strength. Now the next question is, in a spinning mill, fiber bundle strength is preferred over single fiber strength. Yes, fiber bundle strength is preferred. Why it is preferred? Now we'll go with option D here, that it gives benefits of all the above three. That bundle strength test is easy and quick because it is very difficult to handle single fiber. It gives less variation in the results, and it has better correlation with the yarn strength. both the options are all the three options are correct, so we'll go with option D here. Imperfections are sum total. Now the next question is, imperfections are sum total of, we all know that imperfections are sum total of thick place, thin place and neps, so we'll go with option D here. Now the next question is, fiber diameter varies. For a given linear density of the fiber diameter varies with inversely with square root of density, because we all know that density is equal to linear density upon area. So if the linear density is constant and area is considered as circular cross-sectional area, so diameter will be inversely proportional to square root of density. Now the next question is, if D is the diameter, the rate of airflow through a fiber plug during fiber fineness measurement. As now the rate of airflow is directly proportional to fiber denier. We know that rate of airflow is directly proportional to fiber denier, and dia of the fiber is directly proportional to square root of denier. So the rate of airflow will be directly proportional to dia square, that is option B. So we'll go with option B here. Okay, thank you. We'll continue in the next class.